So today we are gonna build a OR gate, the using only the NAND gate, because that's what we want to prove, that we can build an OR gate with NAND gate. So you have right, let me just give you a quickly recap for the OR gate, what it is, and if you know, that's awesome, right? I respect you. So I'm proud of you actually if you know the following the series. So with that said, let's start. So OR gate is a table shown in this, but that's a truth table I have made with switch and light bulb, but it's look actually like this, which is kind of like I don't like this type, okay, which is the normal truth table, so I just converted into bulbs so to make it interesting and remembering, right? That's what we want. And so you can see, right, in normal it's just like 0 1 0, right? In OR table the only thing matters that when bulb is on, when you give 1 the switch will be on, when you give 0 the switch will be off. When the both A and B switch are 0 0 off, then the bulb is off, and when it get any of the switch 1 from any of this A or B, anyone like here or here, so it will on, okay, it doesn't matter. So it just need the 1 to on the bulb, otherwise the bulb will be off. And here we have 1, so bulb is on. Here we have bulb 1, so bulb is on. And here nice condition, we have both on, so it's generally it means on. So let's do to practical with this logically .ly, and make sure you are in demo. If you are in this, then they will send you to purchase it. So come to this link, I will put this in the description so you can have it from there. So let now you have to do with this me, okay? Take this bulb, we are first making an OR gate, okay? So then we can understand how to replicate this with NAND gate, okay? So take this OR gate and put this over here. You're doing with me, right? And take two switch like this, toggle switch, click and hold the switch and drag it over here. Connect this A pin, A switch to A pin, B switch to B pin, and connect the out to the wire of out, or out to output of the LED. So now we know the condition, right? When both switch are off and off, like here we have both switch off, so the bulb is not on. So if we make any changes to this, the bulb will be get on. So now you have to change this, okay? Let's do the A. So now you see A is on. If and this condition is true, right? This one where we on the A switch. Now let's check the B switch on, and we will off the A switch and on the B switch. So B switch, we have to on the B switch, so the B switch is on. Now if both the switch are on, then of course our bulb will be on, right? Because it just the OR only takes one switch to on the bulb. So if both are on, that's mean they are on. So you have to do with me, okay? Do it, okay? So now we did this, great. Now you have to think, just if you don't worry if you don't get the answer correct or wrong. It's like I have taken, you don't believe, but I have taken 15 plus more minutes to figure out myself without I have looked at any the how to make this uh, what we can say replicate this to our let me just replicate this. What we can say, with the NAND gate implementation with the NAND gate. So you have to think how you put NAND gates to behave like AND gate. And so I'm hoping I'm giving you some time. Okay, pause this video, okay, and find out answer how you make or connect these bulbs, right? Use switch and connect this bulb to spark. I'm just giving you a hint so you don't get the time or like easy hint. Okay, so you will need 2 switch, okay, and you will need 3 NANDs, okay, and a 1 bulb. So with this thing you can replicate this OR gate. Okay, you don't need to use OR gate, just use this 3 gate to make this OR gate. So your time start now. Pause this video and figure out how you will make this NAND gate. So 3, 2, 1. I'm telling you how this will work. Okay, so if you got this, it means you are like serious and you are getting the concept. If you not get it, now you will get it. It's easy, right? Now you can get it. I will explain it to you. That's why I'm here, and I will support you, right? And you will also support me, and that's how it goes. So how to make it, right? So to make it, we have to also, let's understand the NAND. Okay, like this we have understand, but very quickly, not taking time. So we take a bulb, how NAND work, okay, then we will build the OR using these items. So let me take a NAND gate. I'm just telling you, you know, right, NAND gate work, how it works. So when both the bulb are on, both switches, it will on, right? So let's connect A switch to A pin, B switch to B pin, and the out to out. So you can see the both switch are off, then only it's get on in NAND. Okay, this is NAND. Okay, don't confuse with OR. I just confused with OR. So if any of this on, right, when you just have to remember in the NAND that it will only off when the both switch A and B are equal to 1. Okay, this both switch together, when here will equal to 1, this is 1, right? Switch are on, okay, then bulb get 0, out get 0. Okay, you understand till here? Clear. So now we understand the NAND, right? In order to off this bulb, we have to on these switches. If any of this switch are off, right, bulb will get on. Okay, so now how to make an OR using 3 NAND gates. Okay, using only NAND gates. So you just put one NAND first, another NAND to here, and another NAND like this. Okay, and now connect this A switch, and this is B switch to this. Okay, let me connect this A switch to A pin, A switch to B pin of, let's take it N1. Okay, NAND chip 1, NAND chip 2, you have to do this with me, okay, and NAND chip 3. Okay, and what you have to do, connect this same what we did with the A switch. So B switch connect to this A pin of NAND 2, and B switch connect to B pin of B NAND 2, and now connect this one, only this one, to N3 A pin, okay, and connect this one to N3 B pin. Okay, now you can see that this is what the current is flowing. You can see over here this blue. This means now this will help us. How to understand this? Now what I want you to understand this part only, what happening, which is now here happening. Okay, the current is passing. Let's connect this. Okay, the third one to out, make sure you connect. So you can see the current is not flowing, right? Why? If you see this much only, now what's happening here? Tell me what's happening here. The current is passing but it's not getting bulb, right? So okay, so this is what happening over here. It's the switch is on, the both switch are off, on, right? You remember, right? The both switch are on, A and B, then it will be 0, right? The current is not passing. So we have to off one of this to make it on. So if I on this, right, don't confuse over here. This is where you can get confused. I don't want you to get confused. So let's on this, and now you see the bulb is on. Why? You see here what happens with this. The current, what happened? The current stop passes, right, over here, which makes the flow disconnected and the bulb gets on. If we on both the switch, then the bulb will still on. Why? Because here it's matter, here this wire matters. Okay, this both are off, 0, this is 0, this is 0. This is little bit understanding part. Okay, if you click on this, then in your mind it also will get clicked why it's not working or why it's working. Okay, so you do some little clicks, then you will get. So you get this part, right? Why it's on? Because both switch. To make it off, I will just tell you what to do. To make this bulb off, what you have to do? Tell me. Okay, if you do it, try to make it off with this bulb off with this switches. Did you make it right? You off it. So now let's see how to off it. So if this will get on and this wire will also get on, blue, it's become blue, then this bulb get off. And now you can see that when we are using this, we have replicated this OR, right? How? Because OR needs 1, right? 1 to on the bulb. Any of the switch is on, then the bulb is on. So if I on this bulb, I am getting the result on, and if I get this bulb on, then also I am getting the bulb on. So we have created this, right, OR gate without using it. Yes or not? We have created it. So that's our video, and we have successfully created the diagram, the gate of NOT using just NAND gates. We have not used OR gate, right? So that's what we want to do, that we can build any gate using just NAND gate. So that's the thing. And let's do wire one, hardware language. This one I know. Okay, this I also hate this one, but it's good practice to do it, right? Because we have done so much of this, right? So if we can do a little bit of this, it would be helpful. And we have to just paste the code here Okay, we have to just replace with your code. You don't have to write your code, and this is just basically telling this that this wire connects to this, and this is not a code also. So I will just put the code description of this code so you can try it yourself. Okay, so copy this code which is in the description, or you can just type it. Okay, so this is not okay, or this is or okay. I have just, you have to do his like paste over here, right? You have to full select this code, remove whatever the code is there, and paste it here. Okay, and make sure you select or from here. Okay, it will be by default and or not. You have to select or. Okay, and now you have selected, select all this and then paste. Okay, the code. So now here not and this, and just run the output and say it step. Okay, this is the step, and this will run automatically. Okay, let me slow down, so let's see one by one. Enjoy. 0 0 0 0 1 1 0 1 0 1 and 1 1 1. So this basically means, right, in the NOT gate what we have simulated is this 1 0 0 means 0 0 0 is this, right? And again what they have given 0 0 1. So the basically this is 0, this is 1, and it gets 1. That's the thing happening. This is the A switch, this is our B switch, and this is our bulb. So that's the thing. And let's see the code, right? Okay, so the code is simple, right? This should be NAND chip, right? This should be NAND chip, and then you have to change that, but you can let it be this code. Okay, there is no problem in this code. It just simply means, okay, what we have here done, we have used the code is not, right? So in A, out, not A. Okay man, let me explain you, because this code is for the not. Then you will shout me, oh, you are using NAND gate and you are giving the example of HDL of NOT gate, which is, yeah, I also believe, right, which is not true. So let's make a NOT. We are making the OR gate now with the help of NOT gate and the combination of this, which is this code. Because of this code we are now making it. Okay, it's good understanding. It will help you to understand more how we are making it. Okay, so they have taken two parts, so not, so we have to take two NOT gate. So NOT gate, like this we will create, and we will put our NAND gate, and for the output we will take bulb, and let's take switch 1, switch B, and connect this. Okay, so what in, right, in A. So oh, it's automatic connected. Oh, this is the different one, my bad. So I thought, wow, I have to not connect now. So this is the, you know, right, A switch, this is B switch, and this is in pin. It's just a name, right? We can call it A, but because here we have A, here we have B pin, just like that, it's just a pin. Okay, we simply call it pin, but for the simplicity we are calling it in the code. So this is in, we are naming it as a in, and here you can see in the code it says in A, which means this A goes to in here. And same you can see here what this means in the second chip, of not, okay, in B. So what it mean? The B switch goes to in, okay, and this okay, this out is not A, which is this one to this, and this is A, and this is B. Pin, it's a pin, right? It's just a pin, and we are calling it as a okay. So pin, B pin, and it's this point is out, okay. This point is also out, okay. And so what this point is? Correct. This is also out. So that's it, what mean, right? So out, not A. So what's happening? Out, A, pin connecting, okay. And so for this also, the second not gate, we have also did the same, not equal to not B. So here it goes to here. And now the final part, which is our NAND gate. So let's see what it's just opposite, right? Not A, so A, and B, so B, not B, not A, not B, and out. What this line means is basically in a opposite way. So let me tell you what this line means. This means here only, okay, they are referring it just this A, okay, just let's focus on this A. This A is just our pin A, okay, and this B is our this B of NAND. Then what's this not A and not B? Okay, this is our not A and this is our not B. How? Because this is not gate, right? So the output, we are calling this out when we for the not gate, but for the AND gate, right, for the AND gate we are calling it as a not A. So this we are calling as, let me use different color, so not B, and this one is not A, okay. And the out is out, the out, this here, this is not another out connected to this out, okay. So that's the it mean. And if we on this, it's now working like OR, right? When the both the switch are on, any switch if on in the OR gate, it work like that, right? So it just need one switch to on the bulb. So that's the thing, okay. I explain it like a little kid, right? But sorry for that. I hope you understand, right? And if any doubt, I will help you. Please comment it and subscribe to my channel, and we will do the make another gate we have used. Maybe we can go with the NOR or XOR and XOR, and we will also understand this, right? These gates to NOR, XOR. We will understand this gate through table also. So stay tuned with me, and you if you will practice this, you will definitely get this, okay. Because if explaining the topic is or watching the topic is like, you will not get it. But if you do it by yourself while watching this video, you will definitely get it, okay, because you know what to do and you are doing. So that's how. So take care and be consistent with your work and enjoy this, right? This is very exciting actually. So thank you for watching this video. Take care. Bye bye.